I mean, think about this for a second. What if your search engine wasn't just some digital filing cabinet, but like a massive multidimensional library that literally rearranged its own shelves every single time you walk through the doors?
Yeah, it sounds completely like science fiction, but honestly, from an architectural standpoint, I mean, it is really the only logical next step for data retrieval. We're just so far past the era where a search engine just hands you a stack of documents and, wishes you good luck.
Right, exactly. Welcome, Deep Divers. I am so thrilled you're joining us. Today, we're cutting straight through all that AI hype cycle noise to look at something genuinely high impact.
Definitely. I mean, we've all experienced that frustration with standard search, right? You have this
Ah,
complex question and you just end up clicking through like 10 different links, manually patching together fragments of information.
oh, yeah, we've all been trapped in that productivity theater. But our source material today, it's a recent MarkTech Post report on the launch of Perplexity's Brain. And it details a fundamentally different approach. It describes a self-improving context graph. So it's less about traditional search and way more about an evolving digital consciousness.
And the architecture backing that up is what we really need to dissect today. Because if you don't update your mental model of how data is being structured behind the scenes, you are just not going to understand how to interact with these new systems.
Exactly. So our mission for this deep dive is to treat this development with absolute PhD-level rigor. We're going to unpack the mechanics of this context graph and in the process, force you to defend your assumptions about how knowledge actually works.
It's going to be a big shift for a lot of people.
It really is. And hey, as we go through this, if you find these wait what moments useful, make sure to hit like, subscribe, and check out our fourth wall merchandise because let's be real, nothing says insight-driven quite like a minimalist hoodie. Seriously, the links are in the description.
Gotta get the hoodie.
You know it. All right, let's get into the architecture. The core claim here is that Perplexity Brain builds a, quote, context graph of an agent's work. What does that actually mean computationally?
Well, to understand the shift, we really have to look at the baseline. Traditional search relies on a static index. It operates on keyword matching and page ranking.
Okay.
So think of the back of a massive textbook. You look up a keyword, it gives you a list of page numbers, and you go to those pages. The index doesn't know why you are looking up that word.
Right.
It doesn't know what chapters you read yesterday. It is entirely amnesic by design. It just treats every single query as this isolated event in a total vacuum.
Right, it's just a directory.
Yeah.
So if traditional search is that static snapshot, this context graph is, it's more like a moving picture. Imagine a city map that doesn't just show existing rows, but actually grows new lanes based on where people are driving in real time.
Oh, I like that.
Yeah, like if it notices you constantly travel from the bakery to the bookstore, it just paves a direct shortcut between them just for you.
That is a really helpful visualization. In computational terms, what we are talking about is a shift from a flat ledger to a relational network. In a graph database, data isn't stored in isolated rows and columns. It's stored as nodes and edges.
Nodes and edges.
Right. A node is a piece of information, a document, a search query, maybe a summarized fact, and an edge is the relationship between those nodes.
But let me challenge that for a second, because I know what people are thinking.
Yeah.
How is a context graph of an agent's work fundamentally different from my web browser just saving my search history and, like, tracking my cookies?
Okay, I see where you're going.
I mean, my browser knows I looked at running shoes yesterday. It targets ads at me based on that behavior all the time. Aren't we just talking about a glorified recent items folder wrapped in fancy AI marketing jargon?
It's a fair question, but there is a massive, and I mean massive, technical distinction between a chronological ledger and a semantic vector space.
Okay, break that down.
So your browser history just logs events chronologically. At 9 a.m., you searched for best running shoes. At 9 or 5 a.m., you searched for knee pain causes.
Right.
And at 9 and at 15 a.m., you searched for physical therapists near me. The browser history just records those as separate receipts. It doesn't fundamentally understand why those events occurred in that specific sequence.
It knows what I did, but not what I'm trying to achieve.
Precisely. But a context graph uses vector embeddings to map the semantic relationships between those actions. When an AI agent acts on your behalf, it isn't just logging queries, it is calculating the high-dimensional distance between concepts.
Wow. Okay.
It links those disparate queries into a cohesive node cluster. It infers the ultimate goal. The system realizes that the running shoes, the knee pain, and the physical therapist are all edges connected to a central, unstated node.
Which is what?
The node that says, the user is trying to start a running routine but needs a holistic solution for joint pain.
Okay, but what if it gets that wrong? Like, what if I search for running shoes because I want to start jogging, but I search for knee pain because I just bumped my knee on a coffee table?
Right, totally different intent.
Exactly. If the system forcefully links those together, isn't it going to give me terrible, conflated medical advice?
That is exactly where the concept of vector distancing and context boundaries comes in. A poorly designed graph would just link everything you do in a given hour.
Which would be a disaster.
A total mess. But a sophisticated context graph looks at the semantic weight. If you search for a coffee table bruise right before knee pain, the system calculates that the semantic relationship between the bruise and the pain is much stronger. The vector distance is shorter than the relationship between the knee pain and the running shoes.
No.
It creates a boundary.
Oh, I see. So it's constantly weighing the probabilities of why I'm asking something and adjusting the thickness of those invisible strings connecting all the data points?
Yes. And the implication for you, listening right now, is that you are no longer interacting with a static database. When you ask your next question, the system doesn't start from zero. It starts from the center of that specific weighted web it has already woven for your project.
Which sounds incredibly compute heavy.
Oh, it is.
I mean, if I'm asking a live question and the system has to go out, search the web, read the documents, and simultaneously calculate the multidimensional vector weights of every single thing I've searched for in the past month just to give me an answer, wouldn't that take forever? Live search has to be instantaneous.
You've hit on the exact technical bottleneck. Live search is incredibly resource-intensive and highly sensitive to latency. You just cannot run massive, graph-wide restructuring algorithms in the milliseconds it takes to generate a chat response.
Right, the servers would just melt.
Pretty much. And that directly leads us to the most fascinating mechanism described in the Perplexity Brain report.
Which is?
Asynchronous batch processing, or, as the source material calls it, the self-improving memory system that learns overnight.
Okay, this is the part that really caught my attention. It literally, sleeps on it. Let me try an analogy here, because it really reminds me of human biology.
Go for it.
We know that human brains consolidate memories during REM sleep, right? We take the chaotic noise of the day, discard all the irrelevant junk, and strengthen the really important neural pathways. We often wake up with solutions to problems that totally stumped us the day before.
Exactly.
Is this system actually mimicking human sleep cycles to tighten its own digital knots?
It is mimicking the function of REM sleep, absolutely. Computationally, what we are looking at is the difference between retrieval augmented generation, or RAG, during the day, and background optimization at night.
So what does the daytime look like?
During the day, the AI agent is acting like a dedicated but maybe slightly frantic research assistant. It is pulling documents, generating immediate answers, and storing raw data as fast as it can just to keep up with your queries. It is totally optimizing for speed.
Right, it's just grabbing files and throwing them on the desk so I can see them right now.
Exactly. But overnight, or basically whenever the agent's compute load drops, the system shifts gears. It stops prioritizing real-time generation and allocates its processing power to heavy graph maintenance.
Oh, wow.
Yeah, it runs algorithms to review the day's nodes, it recalculates vector weights, it looks for redundancies.
So it's looking at the files on the desk and actually reading them, filing them, and figuring out how they connect to the files from last week.
Yes, and crucially, it engages in computational pruning.
Pruning.
This is perhaps the most counterintuitive part of a self-improving system. It has to intentionally forget.
Wait, really? It forgets?
Yeah. Think about it. During the day, the agent might have pulled in 10 different articles about a specific medical treatment you were researching. Overnight, the system analyzes those 10 articles, realizes that 8 of them are just derivative fluff or mathematically distant from your core intent.
And what does it do with them?
It actively drops those edges. It prunes the graph.
Wait. It just deletes the connections. I thought the whole point of an AI brain was to remember absolutely everything perfectly.
Remembering everything perfectly is actually a massive liability.
How so?
If a graph retains every single low-value connection, it becomes overly dense. It starts hallucinating because it has way too many conflicting data points, and the compute required to traverse the graph becomes completely inefficient.
That makes a lot of sense, actually.
Right. By intentionally dropping low-weight edges and consolidating redundant nodes into single high-value vectors, the system actually becomes smarter by knowing less but understanding more.
That is a massive paradigm shift. AI forgetting is a feature, not a bug. It's literally synaptic pruning for a digital brain.
Exactly.
So the next time I log in and ask a follow-up question about that medical treatment, the AI isn't sorting through the 10 articles from yesterday. It's relying on the newly reinforced, pruned structure it built overnight.
Precisely. It doesn't have to waste real-time compute figuring out which articles are relevant, because it already did all the heavy lifting asynchronously while you were asleep.
Wow.
It connects the high-value synthesis from Monday with a massive dataset you had it process on Thursday, drawing connections you never explicitly prompted it to make.
It's the difference between asking someone a question on the spot and asking an expert who has had an entire week to quietly research and ponder the exact nuances of your project.
That's a great way to put it.
If this technology is continuously tightening its own knots and deliberately pruning the irrelevant noise,
Yeah.
it completely redefines what it feels like to interact with raw data.
It really bridges the gap between raw data and actual wisdom. The system isn't just storing your work, it is actively refining the architecture of your thoughts.
Which brings up a really interesting consequence, right? The source talks about the synthesis of an agent's work into a fully integrated brain.
Yes, the wait, what moment.
Exactly. This graph isn't just a repository of facts. It's a web of invisible strings connecting absolutely everything the agent touches. It's infinite context.
Because facts in isolation are practically useless. The value of information is entirely derived from its relationship to other information and to the user's specific intent.
I could totally see how that plays out.
Yeah.
Using a highly contextualized system, it feels like interacting with a jailbroken digital brain that outright refuses to give you generic corporate fluff.
Right, it cuts through the noise.
Yeah, if you ask a standard search engine about a new economic policy, you get news aggregators, political ads, and SEO-driven blogs.
Right.
But if you ask a context graph that has been working with you for a month, it can see the invisible strings between a dense 40-page white paper you had it summarized 2 weeks ago and like a casual question you asked about supply chain logistics 3 days ago.
Exactly.
It weaves those specific threads together to answer your new question about the economic policy.
It bridges the micro and the macro. It completely bypasses the generic layer of the internet because your localized context graph has essentially become a bespoke search engine tailored exclusively to your operational intent.
But hold on, let's explore the darker side of this, or at least the uncomfortable side.
Okay, let's hear it.
If this system is constantly mapping my work, linking my thoughts, dropping connections it deems irrelevant, and optimizing those pathways overnight, is it possible the graph actually understands my underlying intent better than I do?
In a purely mathematical sense, it might.
That's a little terrifying.
Well, it can track multidimensional variables and cross-reference historical data points far better than human working memory can.
So if the system is doing all the heavy lifting of synthesis, are we losing our own agency in the research process? Part of critical thinking is the struggle of the search, right? Finding a dead end, realizing a source is biased, stumbling across a weird article that completely changes your perspective.
It's serendipity of it all.
Yeah. If the AI just hands me the perfectly pruned, highly synthesized answer based on what it thinks my context is, am I just outsourcing my critical thinking?
It is a very natural fear. We have been conditioned to equate the mechanical struggle of research with the actual value of research. But interacting with a context graph is not about losing agency. It's about fundamentally shifting where your human cognitive load is applied.
Shifting it how? From what to what?
Okay, think about how research used to work in a physical library. You spent 80% of your time looking in the card catalog, walking through the stacks, pulling books, checking the index, and realizing the book didn't even have what you needed.
Yes.
That is mechanical retrieval. Only 20% of your time was spent actually synthesizing the ideas. Standard search engines just digitize that mechanical retrieval.
Yeah.
You still spend most of your time clicking links and skimming bad articles.
Right, the productivity theater we talked about earlier.
Exactly. But because the context graph looks at the entirety of your data as a single interconnected web, it completely eliminates that mechanical retrieval phase. We are moving away from the era of searching for things and entering an era of conversing with everything. You are no longer the librarian fetching the books. You are the director of the institute.
The director of the institute. Oh, I really like that framing.
Your agency shifts from the retrieval of data to the high-level steering of inquiry. You don't perform the act of researching anymore. You engage directly with the synthesized knowledge. Your human agency is applied entirely to the final layer. Hypothesis generation and strategic application. Like, what do we actually do with this insight?
It actually elevates the user, but it also raises the stakes.
How so?
Well, if the friction of finding the answers is gone, it forces you to ask much better questions. If you ask a lazy, generic question, the context graph will just give you a highly synthesized, perfectly formatted, but ultimately lazy answer.
That is incredibly true.
The burden of creativity is entirely on us now. We can't hide behind the excuse of, oh, I'm still doing the research. You actually have to produce the insight.
The training wheels are off, the machine handles the context graph, you handle the creative application, but you also brought up a crucial point about serendipity stumbling across something unexpected.
All right, the happy accidents.
There is a real risk there. If a context graph is relentlessly optimizing its vector weights based solely on your past intent, it can create a localized intellectual bubble.
An echo chamber.
Yeah. It might prune out highly divergent ideas because computationally they seem like noise compared to your established goals. As the director of the institute, your job is to occasionally inject intentional chaos into the system. You have to explicitly prompt the agent to explore adjacent low-probability vectors to ensure the graph doesn't become too rigid.
You have to force it to look outside the roads it has already paved. That makes total sense. Okay, we have covered some incredibly dense architectural ground today, from vector databases to asynchronous pruning.
We really went into the weeds.
We did. So deep divers, let's synthesize what we've learned into some actionable takeaways. First, context is king.
Absolutely.
We established that a fact without a relational graph is just noise. The transition from a static index to a context graph means we are no longer looking for keyword matches. They're calculating the semantic relationships between ideas.
Without that context, you are just collecting trivia. The graph architecture is what turns isolated trivia into a cohesive strategy.
Second takeaway, continuous evolution. The Perplexity Brain and systems like it, they don't just store an agent's work passively on a hard drive. It is a self-improving memory system.
It's alive, in a way.
Right. It uses asynchronous batch processing overnight to restructure, prune, and optimize vector weights. It intentionally forgets the noise so it can strengthen the signal.
Which means the tool you use on Friday is computationally different and vastly more attuned to your specific intent than the tool you used on Monday. It compounds its value over time rather than just degrading.
And finally, the shift in agency. The end of fluff. This technology is designed to kill the mechanical labor of research. By giving you the synthesis instead of the search, it forces you to stop acting like a librarian and start acting like a director.
Your value is no longer in finding the data. Your value is entirely in the questions you ask and the applications you derive from the synthesis.
And why does this matter for you, the listener, in a practical sense? Because in a world of absolute information overload, where every single person and corporation has access to the exact same raw data, the competitive advantage is no longer access.
Not at all.
The person or the agent armed with the most highly optimized context graph wins. Period.
That is the new baseline.
That's our deep dive for today. If exploring the architecture of these context graphs sparked a, realization for you, please tell us in the comments. What other back-end mechanisms of AI do you want us to unpack next? Let us know.
We read all of them.
We do. And please don't forget to check the affiliate links in the description for the tools we use to stay ahead of the curve. It genuinely helps keep the lights on and our own context graphs running smoothly.
It certainly does.
I want to give you a piece of homework for this week. As you go about your work, practice looking for the underlying context in your own research. When you are looking something up, ask yourself, what is the invisible string connecting this specific query to my ultimate goal? Are you just looking for an isolated fact, or are you deliberately building a web? Focus on the connections, stay curious, and we'll see you in the next lesson.
But I do have one final provocative question to leave you with.
Oh boy.
We started by imagining a multidimensional library that rearranges its own shelves to perfectly suit your specific needs. But if a system is constantly monitoring your queries, building a context graph of your work, and learning overnight to anticipate your next logical move, how long until the tool stops merely reflecting your intent and subtly begins to shape the way you think?
Oh man.
If the library controls the pathways, it eventually controls the destination. Stay tuned. Our next dive is going even deeper.